Hey, Bogdan Wrzewski here, where we make algebra easy just for you. And in today's video, factoring some difference of cubes. So let's go. Best strategies is always about identifying patterns, understanding how the formula works. You want to simplify your final statement in factored form, and then you verify, which is commonly overlooked step of the strategy. Verify at the end so that you know that you did it right. So let's dive into this example. So we'll start you off with the following. I'm going to divide this binomial by another binomial. And this is an example where we express that division statement into a product as a product of two terms, complex terms. One is a binomial and the other is a trinomial. So we're going to show you how this formula works by utilizing division of polynomials. If you don't know how to divide polynomials, you can watch the other videos that we already explained. This is just a quick review. So I like this example because it has cubic term minus a number, and it is missing those in between terms because they come with zero coefficient. So this is what I did. I expanded a cubed plus 0a squared plus 0a minus 8. So that I have this expanded version of that cubic polynomial where I counted for missing terms so that I can show how that long division fully works. So when you divide it by a minus 2, you know that a cubed divided by a gives you a squared. Then you reverse and you subtract and you proceed with the same step. You divide 2a squared by a to get 2a. You reverse and you simplify by subtracting. You bring the next term down below and you continue. So this is the linear degree for a. Yes, can be divided by a. So the answer is 4. And that completes the statement. There is no remainder. So everything is good. So once we have this division complete, so we can express that as a product. So the divisor is the dividend times the quotient. And this is the difference of squares. Why this is difference of squares? Because I have one term cubed minus another term cubed. So in general, the formula may be expressed like so using variables x and y. If letter A and B are used or any other two letters, it's fine, it doesn't matter. So when you have a difference, you end up with a product of a difference of those terms to the power of 1 times incomplete perfect square trinomial with addition. When you have sum of cubes, you end up factoring it is with x plus y. So this is that binomial where you have sum. So that's a consistent sum with sum times that incomplete perfect square trinomial with minus sign in the middle. So the difference comes with difference times the sum. That's sort of the way for you to remember. And the sum of cubes comes with the product of sum of two terms and negative sign in the middle of that trinomial. So let's apply that into examples and see how this goes so that we understand the pattern and we are able to factor difference of cubes. So 27x cubed minus 64. So the case here is to recognize that 27 is 3 to the power of 3 and x to the power of 3 together will give you 27x cubed. And 64 is a perfect cubed number. So 4 to the power of 3 is 64. So there you go. We have difference of cubes. So once we recognize that the base is 3x and 4, we go ahead. So difference equals 2 the product of binomial where the difference is utilized. So 3x minus 4 times the trinomial, which is the first is squared. So you get 9x squared because 3x to the power of 2 gives you that. The last term, negative 4 squared, is positive 16. And then you add a product in between of the first and the last term. So 3x times 4 is 12x. So now you have this completed and you verify. So now you verify by multiplying binomial times trinomial. So this is 2 by 3. So I supposed to get 6 terms in the process of multiplication, which I did. So I have 1, 2, 3, 4, 5, and 6. And this is the time when you want to simplify by completing it like so. You collect like terms. You have to identify. I have a group of x squared terms. One is 36 with positive sign times x squared. The other is negative 36 with positive with negative sign. So this is 36 minus 36 is 0. Similarly for the 8x and negative 48x. So I have canceled those 4 terms. I shrank this statement into 2 and I'm back to 27x cubed minus 64, which is what I had in the first place. So we can say the question is done correctly. Bingo. Next example. You're going to like this example even more because it provides more complexity. So we have a sum of two binomial to the power of 3. Therefore, we can call it sum of cubes. So you have the formula that was already presented to you. We end up with the sum of the first two terms times the trinomial, which is the first term squared, the last term squared, and the product of the first and the last, which is first and the second, with negative sign. So the sum of cubes expands into the sum of that binomial times trinomial with negative sign in the middle. So since we are always required to simplify it, you don't want to leave it like this. You want to make it as short as possible. Whenever applicable, you must look for like terms and start adding them or subtracting to just simply you group like terms. So x and x is added together is 2x, and obviously 1 and negative 1 is 0. So the first set of bracket is reduced to 2x, and then you have to expand what you have inside here. It's a long process. You do x plus 1 squared, so you expand it to this trinomial. Then this product right here is x plus 1 times x minus 1. From the previous video, you recognize that this is the difference of squares. I'm sorry. So this is simplified into that difference of squares and plus this again perfect square trinomial in expanded form. So we have a long statement inside, and our goal is to collect like terms. So you have x squared and positive x squared. You have one negative x squared. You have positive 2x. You have negative 2x. You have positive 1, and positive 1 because of that negative sign, negative x squared and positive 1. So here you go. You have 2x squared plus 2 minus x squared plus 1. You add x squared terms to get 1x squared and add all the numbers, which is 3. So this is the factored form of that long question where you applied sum of cubes. So hopefully that makes sense. You can rewatch those steps as many times as you wish to get this process down pat. And then the check is also cumbersome because it requires you to expand this binomial to the power of 3 twice, x plus 1 cubed, x minus 1 cubed. So you have 6 terms. No, not 6. You have 4 and 4 because you have 1, 2, 3, 4, and again 1, 2, 3, 4. So when you have binomial to the power of 3 in the expansion, you will have 4 terms. You have binomial to the power of 3 again. In the expansion, you have 4 terms, and you start adding like terms. So x cubed and x cubed, you get 2x cubed. 3x squared and negative 3x squared is gone. So that is the reduction. And then you have 3x, and 3x gives you 6x. And of course, the positive 1 and negative 1 number cancel, you get 0. So in the end, you have something like this. And you may say, how is this equivalent to my original questions? We already did the original question, and we got 2x times x squared plus 3. So all you need to do is to factor 2x from that binomial to show the equivalency. So now you can say the right side is equal to the left side. The verification process is done, so the question is done correctly. So hopefully this makes sense for you. And before you go, do not give up practicing, because this is how you solidify your learning. So practice by using the difference of cubes here, using the sum of cubes for this question. And this is a beautiful question because it has fractional coefficients. We talked about fractional coefficient in the past video, so if you need to relearn it, go and watch that. So don't forget to share and comment down below, and we'll see you next time. Bye for now.